So I notice you've returned to the field. It's good news.
I have got a game this Sunday's going to go well.
Yep, so I'm on the right wing. Are you on the...
Oh, left wing, yeah.
right.
I'll throw it to you and then you'll...
I'll try.
Yeah, well, you should try it. Yeah, so now on to direct proportion.
Yep, and the question we're going to go through is about tension, so it's time to call in another good mathematician like ourselves.
A very famous man.
Yep.
And
it's James Zebedee.
Oh, I was going to say Thomas Young.
Oh, he's probably more famous, isn't he?
Yeah, he probably is more famous, but...
Yeah, so Thomas Young.
Yeah.
He did this thing with tension, and what he said is that tension is proportional to extension represented with an x, and tension is a t.
Now, first we explain what direct proportionality actually means.
Yeah.
So this means that as this number increases, this number will increase as well.
Yep. That's that. So he said if a force of 200 newtons is applied as a tension, the extension would be 8 centimetres. Bloody hell, that's an M, I promise.
He promises. Centimetres.
I haven't seen M in a while. So.
No, I haven't.
And it says, what is the constant of proportionality if you apply this to a spring? Now, T, X, what?
Yeah, well, you see, if something's direct proportional, that's the same as writing that T is equal to K, which is something we don't know yet, which is our constant, times Rx. Now, K will never change in the equation, but we need to work out what it is.
We do indeed. So, you replace the fish with an equals and a K.
Fish.
Is that the person who owns this house? Gil?
It might be Gil. I think Gil has a monocle and a hat there, right? Yeah.
And the monocle, I promise.
That's our fish with monocles, so the other way around because they're fish. Anyway, so you put the numbers you know in. So we have 200.
Yep. Equals this K,
which is currently an unknown, times 8.
So 8K. So to find out what K is, and as Triv said, this won't change when you change the other numbers.
No, this is a constant.
But we don't know it yet.
So you have to divide both sides by 8.
Yep. So 8 goes into 280, 164, so 10, 25 times.
Yeah.
So that's what K is. Your K will be 25.
So then you might ask you to write an equation for T in terms of K and X. So you'd write T equals...
because K doesn't change, 25
lots of X. Then it might say, for this extension, what force is applied?
Yep. Or perhaps in this one, more logically, would be for a different force, how much extension.
It would be.
But either way works, so let's go with yours. Let's say same spring, so the constant won't change, because in the physics world it's the spring that affects. If you get a different spring, it might have a different K.
Yeah.
Let's say it extended 20 centimetres.
Okay.
So if this has increased to 20, this should increase accordingly. So if this has increased from 8 up to 20, it's been doubled and a half. So I'm going to guess that T is going to be 500. Let's see how good that is.
Yeah, see how good that is. So 25 times 20 is the same as 25 times 10 twice, which is 500.
So there's two ways of doing it, but you wouldn't get your marks in the middle section without working out K, so you might as well. And if this says hence, find what T would be with this new extension.
Always use your equation you made.
Yes, because hence means using something you've done before.
Yeah.
So, sorry, I'm getting a phone call.
Oh, no phones in the Cracker Studios.
I know. Oh, I'm getting some news.
Oh yeah. BBC?
Oh, my wishing away. It's M, just got some news for you as well.
Okay. Uh-huh. We actually are back in the field, aren't we?
Back in the field. I'm in the mission with the, and the ant.
Yeah, I'm in the mission with the, and the Declan. We need to get out
out
of here, yeah.